Okay, so we're talking about trigonometry. This was once used to get people across the oceans. Now I'm sure they use it like in rocket science and stuff to, aim the rockets. But it starts with right triangles. That's the basic starting place of trigonometry. And they found out, like, if we know what this angle right here is, this is just an example. It could be different angles, but let's say this was a 30-degree angle. They found out, well, if this is a 30-degree angle and this side is 1, then this side is a 2. Okay, so they recognize that in every right triangle that it's a 30-degree angle. This kind of goes with the similar triangles that we did last chapter. Every time this is a 1, this is a 2. So, or if you had a different triangle that was 30 degrees, and they said, okay, this is 5 long, so guess how long this is going to be? 10. Okay, they found out that they had that relationship every time. Well, what if this was 29 degrees? Well, it's not going to be 5 and 10 anymore. Let's say this one was like 5 still. This one would only be like 9.9. Okay, so, but the point is, if you know this angle, this ratio of these two sides can be known. Does that make sense? And so it could be, but the problem is you can put like any weird little angle right here. If it's 30, it comes out nice and perfect. But if it's anything other than 30, it pretty much is always something weird. So they used to have like giant tables. Probably if you found an old math book, you could find these tables that would like tell you all these ratios. But now that we have calculators, it's all stored inside your calculator. And they stored it kind of with, you guys seen this button on your calculator? Yeah. Okay, I'm going to write this is the only time you'll see these words spelled out. The first and the last time. Sine, cosine, and tangent. Okay, we've used the word tangent before. It's basically unrelated to what it means now. So on your calculators and how we write them, it just looks like this. But I'm going to still say sine, cosine, and tangent. I'm not going to say sin. It's actually sine, cosine, tangent. Okay, so what these functions do, let's focus on sine. What the sine function does is you feed it, all of these functions, you feed it an angle. What a function does is you put one number in and it spits something else out. So what it does is you feed it an angle and it'll spit out a ratio. So do you guys remember at the beginning when I said 30 degrees, that's like 1 and a 2. So what sine tells us is this 1 over 2 part. It tells us the ratio. But actually on your calculator, it probably won't spit out 1 over 2. I doubt it. It'll probably spit out 0.5. Okay. Yeah. But like I said, like 30 is one of the rare cases where it works out pretty. If you change it to sine of 29, it's not going to be so pretty. So, what? Give me the first 4 digits.
4848.
4848?
Yeah.
Okay, so usually it's a mess, kind of like this. There's no fraction that goes with it, but that still is a ratio. It still tells us the ratio of those sides of the triangle. Okay. So there's a magic word that we need to remember, and we'll start now, and we'll do it a lot this year and more next year, and that magic word is SOHCAHTOA. Actually, before I talk about that, go back to my triangle for a second. Okay, well, you remember how I said you always like put the angle into the function? So let's say this is side A, or sorry, angle A right here in this corner. What side of a triangle is this? If it's a right triangle, this is the what side? Hypotenuse. It's a big complicated word to spell. Hypotenuse. You don't have to really remember that, but so what they did is they named these other two sides. These are legs, but they gave them specific names. This leg down here that's close to A, the angle that we're looking at, they call it adjacent. Adjacent is just kind of a fancy word for next to. Okay, so I could say Cadence is adjacent to Natalie. Right, it just means next to. So, well, why didn't they call this one adjacent? Technically, the hypotenuse is also adjacent to angle A, also, right? But since we know this is the hypotenuse, we just call it the hypotenuse. So the adjacent side is the one close to the angle. That is not the hypotenuse. Okay, the one over here that's far away from angle A, if there's like somebody who lives on across from you on the street, do you know a way to say that? Like you could say
Opposite?
yeah. Like you might say Lowe's is opposite. No, Lowe's is opposite of nothing. What's Walmart opposite of some church? Trying to think of something in town.
McDonald's is adjacent.
Well, I'm doing the opposite right now though. What's McDonald's across the street from?
HTO.
Okay. So, yeah, there's two, I think. So anyway, the one that's across the street from is called the opposite. The one that's far away is called the opposite. This side is opposite this angle. Okay, so those are the names for the sides. Here's the trick though. If we're talking about angle A, that's all right. But what if we're talking about angle B up here? This one. So now, angle B, this is still a hypotenuse, by the way, right? Doesn't matter what angle you're looking at, this is the hypotenuse. But what side is adjacent to angle B? Adjacent means next to, so that would be that one. What side is opposite angle B? That one. So it kind of depends on which angle you're talking about. By the way, angle C, the 90-degree angle, we'll never use that for this. This stuff only works in 90-degree right triangles, but you don't use the 90-degree angle for this. It's just one of these acute angles. Okay, so here we go. Darn it. And there, we'll squeeze it in there. Okay, what is this is an acronym. It stands for something. S stands, guess what S stands for? Sine, yeah. And to be a little more specific, it's sine of some angle. Should equal. Anybody want to guess what the O stands for?
Obese.
Incorrect. Opposite. Guess what the H stands for?
Height.
Hypotenuse. So what this means is when you put an angle into the sine function, it's going to spit out, like if you plug it in the calculator, sine of 30, it's going to spit out a ratio that's equal to the opposite and the hypotenuse. So some of you earlier plugged in sine of 30 and you got 0.5 or 1/2, right? That means the opposite is like 1 and the hypotenuse is like the 2. That's the ratio of these sides. So basically the hypotenuse, if it's a 30-degree angle down here, the hypotenuse is twice as big as the opposite there. Okay. What do you think K stands for? Cosine of an angle, it's not just cosine, it's cosine of some angle equals adjacent. Remember adjacent was one of our, I guess I moved it, didn't I? Adjacent was one of our things. Adjacent over hypotenuse. So it gives you the ratio of those two sides. And guess what TOA stands for? Tangent of some angle equals its opposite side over its adjacent. So if I remember right, I'm pretty sure like number 1 on the test, which will be like 3 weeks, is this. So you need to know the word SOHCAHTOA. And I'll ask it if I remember. I'll ask it tomorrow and we'll go over it again, but we'll review it a bunch of times and you'll use it a bunch of times. Okay.
He's always so scary. He's gone now. He's just stalking him.
You're still looking for football players. What's he asking everybody?
Sizes for stuff.
Okay.
We're getting the good stuff this year.
Or getting new what?
I don't know.
We're getting good stuff.
Clothes, football, grit.
Ritter.
Jody.
It's what the flowers are paying for.
I sold like so many flowers.
Did you?
I did. $254.
Good grief. Oh, I thought you were going to say 254 flowers. $254 is probably like
It's like 10.
10 flowers.
I was on a flower grind.
Who bought those?
Did your stepmom buy like half of them?
Kind of.
Yeah.
She bought like $81.
That's a third of it. Okay. Yeah, so let's. Should I do some examples or we should just use number 1 as an example, maybe? Okay. If I only knew these 2 things, guys, how could I find this one?
A squared plus B squared.
Right.
Right.
5 squared plus 12 squared equals this squared. I'm going to go ahead and skip ahead to the answer here. Okay, 13.
This is practice.
All right, yeah, we're kind of slowly working our way towards the actual solving the equation thing. But we're going to practice with just the ratios. So I don't know what angle A is. We're just going to set it equal to its ratio. Okay, in your notes, I kind of hid it up. It's up here, hidden somewhere. What ratio is sine of A supposed to spit out? Opposite over hypotenuse. Okay, so relative to this angle, looking at this angle, what's the opposite side? 5. What's the hypotenuse? 13. So this would equal 5 over 13. Now, if we actually knew what angle A was, and we plugged sine of that angle in our calculator, it wouldn't probably spit out 5 over 13. It'd probably spit out, 0.397, whatever this is a decimal. But this is kind of practice for later. Cosine. So cosine gives us adjacent over hypotenuse. What's adjacent to angle A? 12. What's the hypotenuse? And then tangent of angle A. TOA was the last part. Tangent is equal to opposite over adjacent. So what's opposite of angle A? 5. What's adjacent to A? That's kind of like how it starts, how the lesson starts. All right, let's go ahead and jump in. Number 1. We haven't learned everything, but we got enough to get us going. I'm just going to copy that triangle that he drew in the book here. Okay, you don't have to copy the triangle down, I'm just doing it for. Alright, I'm gonna pick on you guys and go around. Does anybody want to volunteer to start?
Go that way.
I'll do this.
So you start with?
Or maybe this. No.
Just start somewhere. Start.
Yeah, we'll just do Xander. Xander? Okay. What's sine? What ratio does sine spit out?
3 or 5?
What are the sides called?
Oh, opposite over hypotenuse.
Opposite and hypotenuse. Okay. Hopefully, did you guys get that from your notes, right? Remember earlier?
Sorry.
Earlier I wrote this up here.
Crazy.
So,
So go
just from earlier. So, opposite of angle A is 3. Hypotenuse to A is 5. Okay. Kyle, what sides does cosine give us?
adjacent from the
Right. What is adjacent to angle A?
4,
And what is the hypotenuse?
5.
So 405. Okay, Reagan, did you write down what tangent gives us? What is it?
Opposite from
Yes. Adjacent. So what's opposite of angle A? And what's adjacent? Right. So it's just 3/4. Okay. I think you guys will get 2 right, but maybe let's just look at the first one and make sure. So Caleb, let's look at sine of B. Same picture.
Okay.
So it's still opposite over hypotenuse. So Caleb, what's the opposite of angle B?
4.
4. And what's the hypotenuse?
5.
5.
So 4,
4/5, yeah. Would be the first one.
5. Hey.
Okay, I'm gonna go ahead and jump to 3 now though.
That was so silly. Oh, you're so silly. Sorry.
After I draw it. E, D, F. And we're supposed to do sine of D. I'm kind of a little bit concerned because we're doing the bottom left corner every time, and you guys might get confused on the top right, but maybe number 5 will help with that. Okay. I guess we're on that one. So, I wrote the wrong letter down. Okay, Madeline, what would sine of D give us?
55
Right. Opposite over hypotenuse. Okay, here's the problem. Or maybe do you guys know what the problem is? You're not supposed to leave a square root in the denominator normally. How do we fix it? Well, if you got a nice calculator, you can plug in your calculator. But does anybody remember the quick? If you know the trick, you just do times square root of 61 on top and bottom, and it just turns into 5 square root of 61
Over 61.
over 61.
Okay.
So you could use your calculator, but if you know the trick, it's faster not to. But if you're not 100% sure, okay, and if your calculator's not nice, it won't do it. So you could borrow a calculator, I guess. All right, cadence, cosine.
86 over √ 61.
Right. So adjacent 6, hypotenuse square root of 61. So it's going to look very similar to the other one. Alright, Keziah, tangent. Opposite over adjacent. What's the opposite?
5.
the adjacent.
Over 6.
Yeah. By the way, if these fractions would reduce, do you think we should reduce them? Yes. This one, we don't really need to do anything yet, but probably later on we're gonna have to reduce it. 5, 6 does not reduce. Oh, yeah, 5, that'll help. Okay. By the way, this is a 2-day assignment, did you guys tell? Are you shocked? Oh, I think I might have mentioned it earlier. So you do on Monday. On Monday, I think we're gonna do like a algebra review, cause you guys are doing like a testing thing on Tuesday. We do a little bit of algebra now and then, but yeah. Okay. Where are we at? Craig. So, oh, I didn't put the letters in. It's Y, Z, X. Okay, this one's a little bit different because Y is up here instead of down here. So sine is supposed to give us opposite over hypotenuse. So Craig, what is the opposite of angle Y?
6.
Right. And what is the hypotenuse?
2. 13.
Yes, 2 square root of 13. Now, all of these are going to reduce. All these, you guys know how I can tell? 2, 4, and 6. All right, they're all divisible by 2. Again, if you got a nice calculator, it could do it. 6 and 2 reduce to 3. But also, you're not supposed to leave the square root in the denominator. So this is going to turn into 3 square root of 13 over normal 13. All right, Xander, cosine of y. It's adjacent to y.
So 4.
4, and what's the hypotenuse?
2 square root of 13.
So that's going to reduce to 2. So
2
it,
square root of 13 over 50.
all right, Kyle, tangent of y. So that one was opposite over adjacent. What's opposite of y?
6.
And what's adjacent? Yeah, so back in the day, like Christopher Columbus, they used to use somehow the stars to like make a triangle with themselves and measure like what angle they're heading at, so they could like, you know, land on this part of the continent they're trying to hit. It's kind of amazing if you think about it. And if the navigator screws up, you know, they might be 100 miles off. Okay, number 7 is
Mr. Jordan,
what?
you made a mistake.
What?
5.
Oh, I forgot your news.
Yeah, you did.
I got into my Christopher Columbus story. State, okay, so 7 is does everybody have a calculator? Because 7 can only be done with the calculator. Actually, we kind of need to start by solving the missing parts of this triangle. Okay, they did not tell us the hypotenuse on number 7, so how do we find it? We can do Pythagorean theorem. I bet some of your books, people were naughty and wrote the answer in, did they?
What?
No way.
Okay, I'm gonna blame Cadence.
Oh, actually, Ava has.
I'm surprised Kate isn't on. She doesn't know the answers on it.
Let's see, it's a really big number. Before you square root it, it's like 1156. So, after we add those together, what's our last step though? Square root. And it comes out as 34.
Oh, you sandwich. Patty. Hate that. Especially.
I'm kind of a little confused on what we're going for here, but okay. Sine of A.
16.
Okay, angle A was down in this corner again. So sine is going to be 16 over 34. They did say they wanted a decimal approximation though, which is what your calculator would normally spit out. So what's 16 over 34 as a decimal?
47.
Hmm.
That's what's the nearest.
No, well, the directions say rounded to the fourth decimal place.
0.4706.
What did the fifth decimal place say?
8.
It was 5/8.
Yeah.
Okay, so just make sure, it'll be wrong if you don't do this correctly. To round to the fourth decimal place, you have to look at the fifth decimal place. Is this closer to 50 or 60? 60. So, yeah, you need to put 0.4706. All right, cosine of A. What's cosine going to give us? Adjacent over hypotenuse. Okay, now on this, in this case, it doesn't matter if we reduce it because we're just about to turn it to a decimal anyway. You could just do 30 divided by 34. And hit, some of you might have to hit the button that makes it turn into a decimal on your calculator. What do we get on that one?
0.8333.
That's not right.
Oh, did I do it wrong?
That's not what the book. What'd you get?
30 over 30.
Yeah. Okay.
Just the piano.
Yeah.
I know.
88235. So the 5 is big enough to round it up to a 4, right? Okay, and then tangent of A is opposite over, whoops, adjacent, 16 over 30. So that'll be like 0.5 something. I put this triangle on the board earlier. I don't know if you guys probably don't remember what it was, but. Okay, what do we need to do first?
Like, do the algebra.
Yeah, so this is a leg, not the hypotenuse, right? So it's x squared plus 12 squared equals 13 squared. You guys remember the blank 12, 13 triangle on the board at the beginning? I bet Cadence does because the answer's in her book.
I know it.
Is the answer in your book too?
Yep.
This is mine.
Man.
Remember that example?
Yeah.
Yeah.
Yeah, it's well. Yeah, because it's in your book. Anyway, I'm gonna fast forward and just say that comes out as 5.
What?
But you'd have to do this if you didn't know. That is the second most popular right triangle, 5, 12, 13. The first most popular is the 3, 4, 5 that we did on number 1. Okay, sine of G. So sine gives us opposite over hypotenuse. Cosine gives us adjacent over hypotenuse. And tangent gives us opposite over adjacent. I know what that one is. That one comes out nice. The other one's not so much. So yeah, you can just divide those. Round to the 4th decimal place if it gets to the 4th decimal place. Number 11. Number 11 is a messier one. So to find the long leg there, I would have to do 2 squared plus x squared equals 4 squared. Okay, so it's 2 squared of 3 because there's a double 2 inside the 12. Alright, so sine, what are we doing? Which angle are we doing? M? You might notice that there's a little bit of a pattern between the odds and evens on your answers. Okay, anyway, sine of M should give us the opposite, boom, hypotenuse, boom. So opposite 2 squared of 3 over 4, those reduce to square root of 3 over 2. Oh, and I forgot we're supposed to turn it into a decimal. Whatever the decimal is. Cosine of M, oh, I know this one, is adjacent over hypotenuse, 2/4, which is 0.5. Tangent of M is opposite over adjacent. Opposite over adjacent. And that reduces to square root of 3. We can plug that in your calculator. Let's just finish this page. The last few are pretty quick. So we'll just wrap this page up and call it good. So 13 says use a calculator to round it to 4 decimal places. So what's sine of 50 spit out?
Sine of 50.
50.
0.7660.
Yeah. And they did put the 0 in there because you're showing that you're being accurate to that spot. 15. 75.10 of 75.25. Okay, 17, 18, a little bit of a curveball here. 18's even trickier. So, I mean, I kind of wish books would stop putting this in there because I don't know who would use this, but every book has it, so I guess we should talk about it a little bit. Okay. So on 15 we used a decimal with the angle, right? 75, so it's like 75 and a quarter of a degree. On 17, this is called 40 degrees and 15 minutes. And a minute represents 1/60th of a degree. You know how like a minute on the clock is 1/60th of an hour? So what this is worth is 40 and 15/60ths of a degree. So what you can put in your calculator is that. Or if you don't want to put in a mixed number, well, does everybody know how to put a mixed number in a calculator? If not, probably now's a good time to figure it out. So yeah, just plug that in. Should have come out as 0.7632. Okay, and if you thought that one was tricky, buckle up for number 18. 7 degrees, 8 minutes, and 30 seconds. A second is 1/60th of a minute, which is 1/60th of a degree. 1/60th of 1/60th is 1/3600th of a degree. But there's an easier way. So one way we could have done it is just say it's like 30 out of 3600ths of a degree. But there is an easier way. 30 seconds is what fraction of a minute? Half. Yeah, it would still be kind of a mess. Well, there's only one problem like this, so we'll just do this and we'll call it good. So that's 8/60ths of a degree plus 3600ths of a degree. So that would get the job done. We could have done plus 8.5 over 60, but yeah, it's probably more confusing. So we'll call that good for today.